All right, today we're jumping into something really cool, a new AI superpower that's all about seeing in the dark. We're going to break down a research paper called CLIP for VI-ReID. Yep, I know it's a mouthful, but the idea behind it is so clever, it could totally change the game for security systems.
So think about it for a second. You've got a security camera, right? It's tracking someone walking down a sunny street. Easy enough. But then that person ducks into a dark alleyway where the night vision kicks in. For us, it's tough to be sure it's the same person. For an AI, it's been practically impossible. That's the big question here. How do you teach an AI to connect the dots when its whole world changes from light to dark?
And this slide, this just lays the problem out perfectly. On the left, you've got what a normal camera sees, all the colors, the texture of a jacket, the little details. But on the right, that's infrared. It's not seeing light, it's seeing heat. And all that juicy information we use to recognize someone, like the blue of their shirt or the logo on their hat, poof, it's just gone. In the AI world, they call this the modality gap, and honestly, it's been a massive roadblock for years. So this all leads us to the core challenge that researchers have been banging their heads against, the all-weather security problem. It's all about building an AI that can see reliably, not just day and night, but in pretty much any condition you can throw at it, 24/7. You have to understand, for a computer, those two images we just saw, they might as well be from different planets. It's not just a filter change. One is literally made of light data. The other is made of heat data. So we're asking an AI to find a match between two completely different visual languages. It's a huge ask. So how on earth did the researchers crack this nut? Well, they came up with an idea that is, when you think about it, both incredibly simple and incredibly powerful. You know, the old ways of doing this were, well, let's just say, a bit clunky. People tried to force the AI to match the pixels directly, which rarely worked. Or they'd use these really complex models, you might have heard of GANs, the AIs that kind of dream up images, to create a fake color version of the infrared photo. The results were usually just messy and noisy, and the AI would get totally confused. And this is the big aha moment from the paper. They thought, okay, instead of trying to translate pixels to pixels, what if we use something more abstract, something that can capture the idea of the person? What if we just used human language as a universal translator, a kind of semantic bridge to connect these two totally different visual worlds? Now, the secret sauce that makes all of this possible is OpenAI's CLIP. CLIP is absolutely incredible. It basically scoured the internet, looking at hundreds of millions of images and the text captions people wrote for them. Because of that, it has this deep, almost intuitive grasp of how to connect a description, like a person wearing a backpack, with what the actual pixels of a person wearing a backpack look like. Okay, so armed with the power of CLIP, the researchers built their new model. Let's really get into the nitty-gritty of how it uses this text as a bridge idea to finally let AI see in the dark. The magic here isn't just one single trick. It's a really clever three-stage strategy. You can think of it like a detective who starts with a really broad description of a suspect, and then slowly, step by step, zeroes in on them. The AI gradually aligns the two camera views, getting more and more precise with each stage. And here they are, the three stages. First, text semantic generation. Second, infrared feature embedding. And third, high-level semantic alignment. Yeah, they sound super technical, I get it. But the idea behind each one is actually pretty straightforward. Let's walk through it. Now, this first step is maybe the cleverest part of the whole thing. The model starts by looking only at the good picture, the clear daytime image. It uses CLIP's power to write a detailed text description, something like a tall person in a blue shirt carrying a black backpack. Notice what it's doing? It's completely ignoring the messy, confusing infrared image for now. Smart. Okay, so in step 2, that text description becomes the AI's guide, its roadmap. The model now turns its attention to that black and white infrared image, but it's not looking blindly anymore. The text is telling it what to look for. If the text says person carrying a backpack, the AI knows it should be looking for a specific blob of heat on the person's back. The text is literally bridging that modality gap for the AI. And this final stage is all about precision. It's about sharpening the pencil. The AI refines everything it's learned. For instance, it might figure out that wearing a shirt is way too generic to be useful, but the specific shape of the backpack's heat signature is a super unique clue. It hones in on only the details that are actually visible in both images, creating a powerful, unique signature for that one specific person.
So, the theory is brilliant, right? It sounds great on paper, but the real question is, does it actually work? Let's look at the results.
Okay, so how does it stack up against the previous champions, what researchers call the state-of-the-art models? Well, this chart tells the whole story. That rank 1 accuracy score is the big one. It basically asks, what percentage of the time was the correct person the #1 result? Just look at that jump for R's. This new model doesn't just edge out the competition, it pretty much leaves it in the dust.
Let's just focus on that one number for a second, 94.51%. What that means is, if you show this AI a daytime photo and ask it to find that person in a lineup of nighttime infrared photos, it gets it right as the top result over 94% of the time. That is a truly incredible level of accuracy.
You know, this quote from the authors themselves really says it all. Their wild idea that you could use simple words to build a bridge between two completely different ways of seeing. It didn't just work, it worked spectacularly. Okay, so this is some seriously cool tech. But what does it all mean for the future? Why should we really care about this beyond just a single fascinating academic paper? The big takeaway here is that this research gives us a whole new toolkit for building AI. By just thinking about the problem differently, using language as that missing link, we can now teach AI to connect different kinds of senses in a much smarter, more robust way. This isn't just a small incremental improvement, it's a fundamental shift in how we can build AI that truly understands the world in all its messy, unpredictable glory. And that just leaves us with a pretty mind-bending thought to chew on. We've just taught a machine to see across the visible and invisible light spectrums, something no human can do. It really makes you wonder, what's the next human limitation that AI is going to blow right past? Thanks for tuning in.